Hey, good morning, everyone. Hope you all had a good weekend. Just to let you know, I ran into some issues with Zoom over the weekend. It's weird whenever our password for ACES changes, you know, ACES is the website we get into Northwest Vista. Whenever that password changes, my Zoom account becomes completely disconnected from me. And the college every couple of months forces us to update our password. So it forced me to update my password. And when it did that, Zoom became unlinked. So I couldn't make videos. I couldn't get to the old videos from last week. So I just got access to Zoom last night at 10:35 p.m. So obviously the homework solution videos for the last few sections, I didn't get a chance to do. And then I just uploaded the lecture from last week onto YouTube. So I'll be working on getting those up this week. And if you need an extension or something, I can extend the deadlines just to give you, a little more time to watch the videos. So just wanted to let you know what happened and that I wasn't just being lazy. So, all right, y'all ready to get going today? We have an exam coming up. So our schedule has us having an exam on Monday, April 12th, which I believe is a week from today. Yes, it is. So,
like we did last time?
Yeah. I'm sorry?
Are we gonna have a study guide again?
I'll give you some sort of review before the test. Yep. So that test will cover everything we do this week. So today we're going to do double angle and half angle formulas. And then Wednesday, the plan is to do product to sum and sum to product formulas. And so all of that will be on the test. It's going to be a pretty intense test. It's going to have a lot on it. So yeah, anyway, so I will give you a review. Plan to have that to you on hopefully Wednesday or Thursday. Okay. All right, so last class, what we did was we established, what was it, 8.5, right? We established the sum and difference formulas for cosine and sine, and then also tangent. And these two here for cosine and sine are the big ones that you need to know. And remember that all of these formulas are on this formula sheet, okay? They are on the second reference page. So last class we covered this right here. And so today we're covering these two. This is going to be this one and this one. All right, the double angle and half angle formulas. All right, and then there's product to sum, sum to product. I don't even see those on here. Yeah, they may not be here, which is fine. They're not used that much, the ones we do next class. The ones we use today, though, are used a lot. All right, so today's going to be an important day for your future in calculus. All right, so that's what we're going to do. Start 8.6, double angle and half angle formulas. And we'll just get right into the beginning. These are your double angle formulas. Now, what you'll see here, the reason they call them a double angle formula is because inside the argument of the function, the trig function, is 2 times whatever the angle is. So it's double the angle. And so what the formula allows you to do, I just want to take this and let's look at this for a moment. What this allows you to do is take an expression that has some angle, let's say 2 theta in it, and turn it into a new expression that has just theta inside the arguments of the trig functions. So let me show you where this first one comes from. I'm not gonna do this for each one of these, but just to show you where the formulas come from. If I look at sine of 2 theta, another way I could write that would be sine of theta plus theta, because that's what 2 theta is, right? And then we can go back to last class where we had the sum and difference formulas. And we know that if we have sine of alpha plus beta, so if we're adding 2 angles together, it's sine alpha cosine beta plus cosine alpha sine beta. So if I do that formula, to this, right, then this becomes sine of, this is like the alpha, this is like the beta, becomes sine of the alpha, cosine of the beta, plus cosine of the alpha times sine of the beta. But see, these are the exact same thing. This is sine theta times cosine theta, plus, again, multiplication doesn't matter which way you write that. So that means we have two of these sine theta, cosine thetas. And that's what the formula is. You see that? So that's how we would get that one. And then the next ones are found the same way. But what I'm going to point out, though, and I want you to make sure you understand, is that for sine of 2 theta, there is only one formula. 2 sine.
Why would it not be 2 sine of theta, 2 cosine of theta?
Because you're just adding, you're saying this is like, you know, this is x and this is x. So when you add x plus x, you get 2x.
Oh, so the 2 is distributed through.
Yeah, well, this, no, you mean distributed through, like it would go to the sine and to the cosine? Is that what you're saying? No. Look, think of it as x's right now, right? If I have x plus x, that's equal to 2x. You agree?
Yes.
Okay, or if I said, let's say better, this is x times y, x times y. Then if I add those up, I'll have 2 of those x times y's. This does not mean I have 2 x's and 2 y's. It means I have 2 xy's, x times y's.
Gotcha. Okay.
Yeah, I know what you're saying, but it's not distribution. It's the same reason that when you have 2 times 3 times 4, this does not mean 2 times 3 and the 2 times 4. It just means whatever 3 times 4 is, 12 times 2, which is 24.
Gotcha.
Right? Okay.
Thank you.
Okay, so for sine, we only have one formula, right? You can't really go wrong with sine. But with cosine, we actually have 3 equivalent formulas. All of these are the same thing. And the reason, you know what, maybe it's worth us doing one of them. Let's do this one. Let's do cosine of 2 theta, and let's see if we can figure out where the formulas come from. This is cosine theta plus theta, right? That's what it means. And then if we go back to last class, we could use this first formula here, which says we'll do cosine alpha, cosine beta minus sine alpha, sine beta. Right? So if I do this formula here with what I just put down, I should get cosine of the alpha, cosine of the beta, but since alpha and beta are the same thing, it's just cosine theta, then minus sine theta, sine theta. And that equals cosine squared theta minus sine squared theta. Does that make sense, everyone? That's your first formula. Now, where do you think they get the second formula from? Anyone have any ideas of how they get the second formula? What is it
Using
missing?
the Pythagorean identity.
Isn't it missing cosine, right?
That's right, it's missing cosine. So what they do is they take this cosine squared theta, and I think Maddie said this, using the Pythagorean identity, which I'll put to the side here. Remember, this is like one of the most important identities we have. Remember this identity here. Oops, I forgot my theta. Using this identity here, if I solve it for cosine and move the sine squared to the other side, I get cosine squared theta equals 1 minus sine squared theta. And so if I replace cosine squared theta with 1 minus sine squared theta, and I already had a minus sine squared theta, then when I put these two together, I have 2 of the sine squared thetas. And so you can see where the second formula comes from. Does that make sense? And then what about the third formula? Where do you think this one comes from?
Using the Pythagorean theorem identity again, but instead solving it for sine squared theta.
Yeah, so it's the same idea that we had here, but instead of doing this, instead of replacing the cosine squared with this, What if we do this formula? I'll write it down here again on the side. What if we did this? But this time, let's replace sine squared theta. So if we go back up to this identity over here and solve it for sine squared theta instead, move the cosine squared to the other side, we get sine squared theta equals 1 minus cosine squared theta. So if I take that and replace it here, you have to be careful because you have a cosine squared theta up front, then you have a minus sign. This is the part that's tricky, minus. Now sine squared theta is 1 minus cosine squared theta. I have to have that in parentheses. And then distribute the negative through. So it becomes -1 plus cosine squared theta. And now I can put these two cosine squareds together. So I'll have two of them, two of the cosine squared thetas, -1. And that's your third formula. So you might be wondering like why it is there are three formulas. Well, it turns out later in calculus that sometimes you'll want to use this. Well, actually in here too. Sometimes you'll want to use this one. Sometimes you'll want to use this one. And sometimes you'll want to use this one. It depends on the problem. And you'll see when we work through some of these, like when it is you'll choose which one. But you're always allowed to use any one you want. Okay, you're free to use any of the three. So, all right, but that's it. Those are the formulas. Okay, those are the first group of formulas for today. Those are called the double angle formulas. And now let's just kind of see how we can use these. All right. So our first example is to find the exact values of this, of what they're asking using the double angle formula. So first of all, they give us some information. They tell us that sine of some angle theta is equal to 3/5, right? And they tell us that theta is between pi/2 and pi. And then they want us to find the exact value of sine of 2 theta and cosine of 2 theta. So I'm going to start with what I'm given. I'm told that sine of theta is 3/5 and that theta is between pi/2 and pi. So I'm going to kind of draw a picture of where I am. Let's see, pi/2 to pi, so I can't be in the first quadrant, can't be in the third, can't be in the fourth, right? And I'm going to remember that by definition, sine of an angle is the y coordinate over r. So this is going back to that definition of sine. Remember, we had 3 different definitions. We used this last class. This means the y coordinate divided by r is sine of theta, and that's equal to 3/5. So in order for this to match up, I imagine that I have a point out here. I know the radius here is 5, that comes from this, and the y coordinate of that point, the y coordinate should be 3. And so the only thing I don't know is what the x coordinate is. Does that all make sense? Now we can do this by right triangle. We know that this side is 3, and we just have to remember that if this is x, whatever our answer is, it needs to be a negative x value because we're in the second quadrant. So when I solve for x here using Pythagorean, x squared plus 3 squared equals 5 squared, you should get x is equal to plus or minus 4. I'm not showing the work for that only because we've done it a few times, many times now. And then I'm going to throw away the positive answer and use the negative because of what quadrant I'm in. So this is -4. Now, the reason I did that is now I know what sine theta is, right? Sine theta was given, but I also know what cosine of theta is. If I need it, I know what it is. I also know what tangent theta is. I know all the reciprocals. I know everything I need to know about theta, all the trig functions of theta. Now let's do part A. So sine of 2 theta using the double angle formula is going to be 2 sine theta cosine theta, right? And I know those, right? Sine of theta was given to me as 3/5. And cosine of theta, remember by definition, cosine of theta should be the x over r, right? The x coordinate divided by the radius. And for us, that is what, -4 over 5? So now I just look at these as fractions and I just multiply straight across. So I've got 6 -24 on top, and then 5 times 5 is 25 on the bottom. And that's my answer. Any questions? Okay, how about part B? Now we want to know what cosine of 2 theta is. Okay, so when it comes to cosine of 2 theta, I have 3 different formulas I can use. Who wants to tell me which one they would use and why? What's the best one to use here? There is a best one.
One minus 2 sine squared of theta.
Yeah.
Okay, so why would you use this one? That is correct, but why is this one like the best one to use?
Because you only need to know sine, whereas if you did any of the others, you would need to know cosine and sine, or just cosine, but we already have sine.
That's right. So this formula requires all we need to know is sine of theta, right? And that's given to us in the problem, so we can't mess it up, right? See here, if you use this formula, you're gonna have to know cosine theta and sine theta. Well, cosine theta we had to find. So if we made a mistake, then this part's gonna be wrong, right? And the last formula needs cosine theta, which we found, but again, if we made a mistake, it's gonna be wrong. So I think the second formula is the best one to use because what it requires is given, and we can't really screw that up. Well, you can always find ways to screw things up, but I think we'll be safe here, all right? So we're gonna use that one. Now just pay attention here. This is what this really means. This really means sine of theta squared. We've talked about this many times, but I just gave a calculus test and my students still don't get this. This squared means you're squaring the sine theta. Doesn't mean you're squaring the theta, okay? You're not squaring the 2, you're just squaring the sine, all right? So here for us, we're gonna put 1 minus 2, and then in the parentheses goes what sine of theta is, which was given to us as 3/5. So this is the fraction 3/5. And now we square our fraction, so you square the top and bottom. So this is 9 over 25. And then you go ahead and multiply 2 times this fraction, gives you 18 over 25. And now you need a common denominator between these two. So you multiply top and bottom by 25 here, you get 25 over 25 minus 18 over 25. And that gives you 7 over 25. There you go. So go ahead.
Yes, sir. So basically, with the 4 equations that we have, we can look at each problem and determine which one to use for each problem.
Well, if they're asking for sine of 2 theta, you only have one choice.
Okay.
Right? But if they're asking for cosine of 2 theta, then you have 3 choices. And I think that would depend on, like you could use all of these. All of these would give you the same answer, okay? Like just for example, if I would have used this one instead, right, 2 cosine squared theta minus 1. If I did that one instead, cosine of theta we found to be -24 over, oh, sorry, no, what was cosine of theta? It was -4 over 5, then -1. Understand? I'm using cosine theta, which we found off of here. Now squared. If I now square that, that gives me 16 over 25 minus 1. And then I double this, so it becomes 32 over 25 minus 1. And that's 32 over 25 minus 25 over 25, which again gives you 7 over 25. I went through that fast, but I'm just trying to show you get the same answer. So if you're doing sine 2 theta, there's only one formula. If you're doing cosine 2 theta, you can use any of the 3, but I would always recommend using the one that includes information that was given to you as opposed to information that you had to find. So let's just kind of just think about what's happening here. We are given some information about sine of an angle, right? And from that, we can figure out what sine of twice that angle is and cosine of twice that angle. And so if you know what sine of twice that angle and cosine of twice that angle are, then obviously you know what tangent of twice that angle is, right? Because tangent would just be the sine of 2 theta over cosine of 2 theta. So you know all the 6 trig functions now of 2 theta also. What about the answer? Sine of 2 theta is going to be the y coordinate, right? Think about this. Doubling the angle, right? Doubling the angle, we got a negative number for sine, which means this angle 2 theta should be either in, which quadrant would it have to be in? If you get sine of an angle is going to be negative, which quadrant would you be in here?
The third or fourth.
Third or fourth. So we're in here, right? Somewhere. Double the angle. Okay, not the original angle is in the second quadrant. But if we double the angle, our answer is negative, which means we're in one of these 2 quadrants. And that makes sense. I hope it makes sense, because think about the original restrictions on theta. I'm going to bring this down here. If theta was between pi over 2 and pi, right? Then if I double the angle, double this, then I double that and double the other side. So double everything. Here the 2's cancel, you get pi is less than 2 theta is less than 2 pi. This is saying that doubling the angle should be between pi and 2 pi, which is either the third or fourth quadrants, right? So the fact that this is negative makes sense, I hope. And then cosine is the x coordinate. So our x coordinate was positive. So which quadrant would we have to be in if we doubled the angle and got a positive number?
1 and 4.
Yeah,
We'd
well,
either have to be in 1 or 4, right? We would either have to be here or here. Oops. We'd either have to be in one of those, right? Well, it has to be 4, right? It has to be 4 because 2 theta has to be between pi and 2 pi, but getting a positive answer here tells us that we have to be either in 1 or 4. So the only thing they have in common is this. So I can tell you right now, just by the work we've done, that 2 theta, that angle, is in quadrant 4. I can tell you that. I can't tell you what it is. I mean, I could use a calculator to do it, but we know that doubling the angle is in quadrant 4, just by the fact that this is negative and this is positive. Okay, let's do another example. So they want us to develop some formulas on our own here. So the first thing they want us to do is create a formula for tangent of 2 theta. See, they didn't give us one, right? The only formulas that were given were those right there. Okay. And they want us to create a formula for tangent of 2 theta. I'll put this here just so we have it. All right, so let's do part A here. So for part A, there's a couple of ways to do this. You could write down tangent of 2 theta equals sine of 2 theta over cosine of 2 theta. That's one way you could do it, right? And that is correct. That's what tangent of 2 theta is. And we actually have formulas for both of these. So I'm gonna stick with this. I'm gonna say this is 2 sine theta cosine theta. Oh, I forgot to mention, look what it says here. Develop a formula for tangent of 2 theta in terms of tangent theta. So they want our final answer to have tangent in it, tangent of theta. All right, so right now I did this, I got this, and then on the bottom, what can I put on the bottom? Well, I have 3 choices, don't I? I have 3 choices. Which of these would you like to use? And it doesn't really matter which one we use. Do you care? I don't care.
I like
Try
a 1
something.
minus.
You want to do 1 minus sine squared, 2 sine squared? Okay. So this is a formula. This is a formula for tangent of 2 theta. Does everyone agree? According to these two formulas, this would be correct in terms of this is a formula, right? We have a formula for tangent of 2 theta. But the problem is it's not in terms of tangent of theta. This doesn't have tangents in it, does it? This has sine and cosine. And because there's subtraction down here, you can't split this into 2 fractions. So this looks like it's going to be a bit of a challenge to get in terms of tangent of theta. So maybe there's a different way we can do this, a different approach. And so I'm gonna ask us to rethink this problem and do it this way. So this is kind of like we did before when I was showing you where the formulas came from a second ago. What if we do tangent of theta plus theta? Now that goes to last class, and I need to go grab the formula from last class. Here they are, right? Here are the formulas from last class. These are the ones that are real important, sine and cosine. But we also last class learned that there are sum and difference formulas for tangent. And if I take this top one here, right? The great thing about this formula is that it's, where are we? That formula, which I'll just pop it right here. Oh, maybe not. I'll put it underneath. If we follow this formula, the good thing is that the answer, right? Look at the answer. The answer has tangents in it, right? And all we're going to be doing is replacing all of our alpha and betas with thetas. So it's just theta there, theta there, theta there, theta there. And that's an answer, right? It's tangent of theta plus tangent of theta over 1 minus tangent theta times tangent theta. And that would give us on top 2 of the tangent thetas, because we're adding them together. And then 1 minus tangent squared theta, because we have tangent theta times tangent theta. So tangent squared. Now this is a formula for tangent of 2 theta that has tangent theta in it, which is what they wanted. All right, so does everyone understand how the first way I did it here is correct, but it's in terms of sine and cosine? The second one is better because it also has everything in terms of tangent theta, which is what they wanted. Questions there? All right, let's do the second part. Develop a formula for all right, here we go. So develop a formula for sine of 3 theta in terms of sine theta and cosine theta. So we have a 3 here now instead, right? This makes a big difference because the formulas we have, okay, are double angle formulas. They only work when you have 2s in here. These formulas do not work when you have 3s. So we have to do something a little different here. So I'm going to show this to you and then you just kind of like go, oh, okay, yeah, I guess we could do that. So do you agree with this? Do you agree that sine of 3 theta could be written as sine of 2 theta plus theta? Right, that is still 3 theta. And then I could go back to last class because this now looks like an alpha and a beta, and I have a sum in a sine, right? So last class we learned that, oh, you know what, sorry, forgot I put it on the first page here just for this reason. So we learned last class that if you have sine of alpha plus beta, it's sine alpha cosine beta plus cosine alpha sine beta, right? So you know what, I'll grab it. So here, so let me drop this thing right here. So this should turn into, let's see, let me call on somebody today. Just looking to see who's here. Jackson,
Hello.
how's it going?
Pretty good.
Good, good. All right, so Jackson, how about you tell me, are you following this, Jackson?
Yeah, I think so.
Okay, so you tell me using this formula with this expression, what this next line is going to be here.
Would it be sine 2 theta cosine theta plus cosine 2 theta sine theta?
Sounds good. What do y'all think, everybody? Does that look right?
I agree.
Okay, good, good. This is right. Now, notice I did not put parentheses around the 2 theta. Do y'all see that? This is one of those places where in math you have to be careful because it's just notation, and it's understood that this 2 theta is inside of this sign. I'm only doing this because a lot of times in textbooks, they'll leave out the parentheses. I mean, technically there is a parenthesis here, and that 2 theta is inside this sign, and this theta is inside that cosine, and this is inside that cosine, and then this theta is inside that sine. I'm just trying to get you used to the idea that later on, as you go through and look at textbooks, they may not have the parenthesis. It's bad notation, but it's just understood and implied that that 2 theta is in there. All right. What I'm getting at is you could argue if somebody wrote down cosine of 2 theta without parentheses, you could argue that this means cosine of 2 times theta. You could argue that, and I wouldn't be able to defend myself because I wasn't clear by writing 2 theta down that the whole thing is inside the cosine. So the only way to absolutely be sure is to put a parenthesis. Do y'all understand that? But you're going to see it, okay? You're going to see it as you move down the road. You're going to see cosine 2 theta, and you're just going to have to say, okay, they mean the parentheses is around the whole thing. So, all right. All right, so good. This is good. Jackson, this is right. We wanted to use the formula. Now, let's move on to somebody else. How about Michael M? You there? Michael M? No. Okay, how about Samuel?
Yes,
Okay, how's it going, Samuel?
I'm good.
Good. Okay, so have we done what they've asked us to do? Have we developed a formula for sine of 3 theta that's in terms of sine theta cosine theta?
Yes,
Okay, so I agree there is sine theta here and there's cosine theta here. What about the other stuff though? That's sine of 2 theta, right? And cosine of 2 theta.
hmm
But they don't want anything with 2 theta in it. They just want sine theta cosine theta in the answer. That's all they want. Do you see that? You see that, Samuel, that we don't quite have it the way they want it yet?
yes.
Okay, so is there anything that you could do, Samuel, to take care of turning that yellow thing and that yellow thing in terms of sine theta and cosine theta? So like, what could you do to this? So do we have a formula for sine of 2 theta?
Yes.
Yeah, that's what today's about, right?
Mhm.
Here it is right here. So this should turn into 2 sine theta cosine theta, right?
Mhm.
Okay, so I'm just going to do that here. I'm going to do 2 sine theta cosine theta. That takes care of that. Now I still had here a cosine theta next to that. Plus, all right, so Samuel, on this next one, cosine 2 theta, you have how many formulas to choose from?
I believe it's 3.
3, right? And it's your choice here. It doesn't tell us, it's not telling us which one to use. So really you get to choose. So I'll let you choose. Which one do you want?
I'll
What's the
choose
Yeah.
the 1 minus 2 sign.
Squared theta, you want that one? Okay, so I'm going to replace that right here with 1 minus 2 sine squared theta, and then sine theta. Also, Samuel, notice I put it in parentheses, right? Because it's 2 terms, right? They're separated by a subtraction, and then you have to multiply times this sign. So if you're going to multiply these together, that sign would have to go through the parentheses to both of these. That clear, Samuel?
Yes.
Okay. All right, I'd say we're almost done. I'm just going to clean this up. This is going to become 2 sine theta cosine squared theta, because I'm do cosine times cosine. And then Samuel, you're almost off the hook here. Distribute this through, Samuel. Tell me what you get.
It will be plus sine theta
Yep.
and then minus 2 sine cubed.
Cubed.
Theta.
Good. Theta. Good. There we go. All right. Thank you, Samuel. You're off the hook. This is it right here. We have an answer. It's in terms of sine theta and cosine theta. Yes, some of them are squared, some of them are cubed, but everything is in terms of sine theta and cosine theta. Now, this is not a formula you have to memorize, okay? This is just showing you how you could figure out what sine of 5 theta was and get it in terms of sine theta and cosine theta if you used enough of the formulas, right? Any questions there? So you could, how about this? Could you do this? I mean, with that same logic, could you find a formula for sine of 5 theta? I mean, you could, right? You could do, I don't know, something like this is sine of 2 theta plus 3 theta, maybe. And then this is like your alpha, and this is your beta, right? And you use the sum formula. And let me do this. This looks like this would be kind of a nightmare, but it should be. So if we use this formula again, right? This right here, we should get sine of the first one, 2 theta, cosine of the other one, 3 theta, plus cosine of 2 theta, sine of 3 theta. Right, that's that formula. And then I've got bad news, because this, yes, we have a formula for it, right? This, yes, we have a formula for it. But what about the green one and the blue one?
You'd have to break it down again, correct?
Yeah, you would have to do exact. So like, if you look, this right here, just this alone is the previous problem. So we would have to go through everything we just did on the previous problem to do that. And then this one is, again, its own problem, but you know, we haven't done that one yet. This one, you'd break down 2 theta plus theta, and then you'd keep going from here. So it would be a lot of work, but I'm just showing you now you could, in theory, do it.
Would it be possible, or would it like ruin the formula if you did in the original equation sine of 2 theta plus 2 theta plus theta?
So in this right here, do sine of
Would it be
2
possible to
theta
have 3 terms?
plus 2 theta plus theta. I'm glad you're asking this. Well, you could if you knew what this turned into. But see, the thing about the sum and difference formulas that we established last class, they only work when you have addition or subtraction between 2 terms. Now, does that make sense, Maddie? I mean, there is no formula that we have that says alpha plus beta plus some other, you know, angle. So we don't have a sum formula with 3 things being added inside. So there's no short way to get to it. We still would have to only look at it as two things. We would still only have to say, okay, we can look at this as like our beta and this is our alpha, and then do our formula. But you would wind up doing the same thing you're doing here. Does that answer your question? Yes. Okay. Now, here's something I don't want you to ever do. Okay, this is very bad. All right. I want you to see if you have sine of 5 theta, this is not and never will be 5 sine theta. That's not the way trig functions work. Trig functions are not like a set of parentheses. Like, you know, all our lives we'd see like expressions like this, and you were told to like distribute the 5 through, right? So this is 5x minus 15. Or here they have a common denominator, a common factor. You can pull the 5 out and have this. If you have a 5 inside of a trig function like this, you cannot pull the 5 out. Okay, this is a major, major, major mistake. This is something you do not want to ever do. If you do it in calculus and you demonstrate that to your teacher's going to be very frustrated because they're going to realize you really don't understand how trig functions work. It's common to see it happen, but it's just, you really want to just kind of like never do this. All right. I don't like to show like incorrect things, but this is just one of those things I really want you to make sure that you're aware of. Life is not this simple. Okay. Sine of 5 theta is very complicated. It's a lot of work to figure out what it is. It's not just 5 sines of theta. That's not the case. Okay. We ready to move on? Okay, the next formulas, okay? So these formulas, they don't have a name here, but they, let me make sure they're on your formula sheets. See what they call them on the form. No, yeah, here we go. They call these the half angle formulas on your formula sheet. Okay, half angle formulas. I refer to these, please learn them as your half angle formulas, but I refer to these as, and other textbooks do also, the power reducing formulas. Okay. Now, do y'all see this symbol over here on the left-hand side? This came out of these formulas. I just copy and pasted them from your textbook that you're using. In your textbook, anytime you see this symbol next to something in that textbook, that is supposed to tell you as a student that this is a calculus thing, that pay attention because this is going to be in calculus big time. And that is true. These two formulas are critically important in calculus. In calculus 2 and cal 3 and cal 1, cal 2, cal 3, all of them. This formula is going to pop up. Same with the previous ones, but they just, I don't know why they put this here. All right. So let's take a look at what the formula is saying first. All right. Let's look at the first one. The first one's saying, if you ever have sine squared theta, all right, and then remember what that means. This really means sine of theta squared, right? That's what that means. So if you ever have sine squared theta, it can turn into 1 minus cosine 2 theta all divided by 2. Now, next to this, I'm going to write it a different way. And I invite you to write this on your formula sheets. Feel free to write that on your formula sheet this way if you'd prefer. So like on our formula sheets, it looks like this. Here and here. If you would like to, and also notice they use x not theta. Same thing, it's just a dummy variable. So they write it this way, but I invite you to write it this way instead. Do you see this is the same thing? You can split this into 2 fractions. Make it 1 over 2 minus cosine theta, 2 theta over 2. And since these both have a 1/2, you can pull the 1/2 out. and you get this. So do you all agree that that's the same expression? Any questions on that? Why this is the same? So what's happened here is we started out with a trig function, right? Sine that was being squared. And look at the final expression. Do you see we no longer have anything being squared? Yes? There's nothing being squared anymore. And so what we've done is we've reduced the power. The power's gone from squared down to no squares. And so that's why it's referred to as the power reducing formula. Now, there's a give and a take though. In order for us to reduce the power and get rid of a squared, we actually wind up doubling the angle. Do y'all see that? Started out as sine squared of theta, but our final result has something with 2 theta in it. So that's the balance. The power comes down in the formula, but the angle doubles. Same with this formula for cosine squared. And do y'all see these are the exact same formulas? Just a plus here and a minus here? It's the only difference. So this one you could write as 1/2 and then 1 minus cosine 2 theta. Plus, oops, 2 theta. Now this one, even though it's here, we don't use this one as much, but all it is take this one and divide it by this one, and then flip and reciprocal, and the 2's cancel, and you just get this formula. Okay, power reducing formula is, like I said, major, powerful formula. I'll actually show it to you in a second, but let's see it in action first. Oh, wait a minute, I thought there was an example here. There we go. Okay, here we go. Here's your first example. And I'm going to scroll up so we can see these. And I think for now, I'm going to delete that one so I can see the formulas up here. All right, so the instructions here. Write an equivalent expression. Okay, write an equivalent expression for cosine to the 4th power of theta that does not involve any powers of sine or cosine greater than 1. So we start out with cosine raised to the 4th power, and we want a final answer that can have sine or cosine in it, but the power on those sines or cosines cannot be greater than 1. All right, you ready? Now, and I'm sure you might be sitting there going, why in the world would I ever need to do cosine to the 4th power and write it in terms of sine and cosine without a power? I'll show you in a moment where that actually comes up in a problem. And then you'll just have to like, oh, okay, I guess it's worth it. All right. Okay, here we go. So I'm going to write down cosine to the 4th theta. Now, do we have a formula for cosine to the 4th theta? No, we have a formula for cosine squared theta. So what you can do is you could write this as cosine squared theta squared, couldn't you? I mean, that's what it means to raise something to the 4th power. It's like you square it and then square it again. Now, on the inside of the parentheses, this cosine squared theta, do you all agree that it is this in red right here? That's what it is, right? So I'm going to say that this is equal to, okay, something squared. Now, the something here is 1/2, and then 1 plus cosine 2 theta. Right? That's what this is, according to the formula I just gave you. Questions there? Now, you may look at this and say, okay, I'm done, because I have a cosine 2 theta, right? And it's not being squared, right? This is not being squared. But the fact that you have a square on the outside of all of this means that if you did actually square this, it would become squared now. So you're not done, all right? You got to keep going. So next step, this is multiplication right here. Anytime you have 2 things being multiplied and you're going to square them, that means you square each one. So I square the 1/2. So 1/2 times 1/2 is 1/4. And then I have to square this. right? I have to square everything in parentheses here, and then I have to square the 1/2. Any questions on that step? Now I'm going to go to the side, and I'm actually going to square that. Right, so to square this in parentheses, I have to do this, and I have to FOIL. So I have to do 1 times 1, that's 1. Whoa, 1 times that, that's cosine 2 theta. Here to here. Why don't I give you a minute to finish that off? I'm going to call on somebody. I want to see what someone gets here. I'm just going to give you like a minute to put those together. And I'm going to be calling on Cameron in a minute. Are you ready, Cameron, or you want a little more time?
Just like 20 more seconds.
Okay.
Okay.
Yep, that's fine.
Okay, I think I'm ready.
Okay, so just tell me to continue here with this foiling.
Okay, so then I got plus cosine of 2 theta
Okay, that's the
Right.
inner multiplication. Go ahead.
plus, and then cosine of 2 theta squared.
Squared. So what I'm going to do this in a different color so everyone can see it.
Okay.
You all see this last piece here? This is very important. You do cosine of 2 theta times itself, cosine of 2 theta. That's cosine of 2 theta squared. Good. Now, Cameron, can you do anything else to simplify this?
Yeah, you can combine the cosine of 2 thetas.
So what will you have? You're saying the 2 middle ones come together to be?
But then it would be plus 2
Mhm.
cosine of 2 theta,
Yeah.
and then the cosine square.
Okay, everyone see that? That is what this is. So now I'm going to come back over here. I'm going to write this out. This is equal to 1/4. Okay, now in all of this becomes this. So 1 plus 2 cosine 2 theta plus cosine squared 2 theta. All right. We good so far? We're not done, right? We're not done because our answer at this point has a squared in it, and it's telling us we can't have any powers of sine or cosine that are greater than 1. So at this point, what I would like to do at this point, and you can do this different ways, I'm going to distribute the 1/4 through. Okay, I'm going to do that. You'll see why hopefully in a minute. 1/4 comes through, hits 1, becomes 1/4. When 1/4 hits a 2, it becomes a 1/2. And then I have a 1/4 sitting in front of the cosine squared of 2 theta. Now, the reason I like to do that is because of my next step. And maybe Maddie can explain why, what I'm going to do next.
Can you repeat that one more time? My audio keeps cutting out.
Yeah, no, I'm asking, what is next? Like, what would the next step be? Because we don't have it in terms of sine and cosine with powers that can't be greater than 1. So do you see where I have a power greater than 1?
Yes.
Okay, so what can you do to that? What can you do to this to make it where it no longer is squared?
Take the square root of it.
No. Do you have a way of, Maddie, do we have a way of reducing the power? Do we have a power reducing formula?
Yes.
Yes,
But
right?
isn't that,
It's this right here, isn't it?
but isn't that the formula we're trying to prove?
No, we're not trying to prove this formula. We're trying to take an expression like cosine the 4 theta and just rewrite it so it no longer has powers. That's all we're trying to do.
Okay,
So-
yeah, then you would substitute, it would be 1/4 times 1 plus cosine of 2 theta over 2.
Okay, so we can use this formula again, yes? Does everyone agree we can use this formula again? However, this formula has theta in it, right? What do we have inside of our cosine?
2 theta?
2 theta. So how do you think that's going to affect our answer? If this is 2 theta, what do you think it's going to become in here?
4 theta?
4 theta. It's going to double whatever angle we have. All right, that's a critical point of this. Anytime you use this formula, whatever comes in here gets doubled. Right, we're going to double that angle. So let me write it out. And also, by the way, I'm going to use this one. Okay, I'm going to use that one. All right, I'm not going to use this one. That's just personal choice. And again, if you're going to take calculus, it's much easier to work with this than it is to work with this. Just that's my opinion. So here I go. I'm going to write 1/4 plus 1/2 cosine of 2 theta plus 1/4. And then now here comes the formula. The formula for this right here is this right here. But instead of 2 theta, I'm going to double the angle that's there. So doubling 2 theta becomes 4 theta. So I'll have 1/2 1 plus cosine of 4 theta. Any questions on where that came from? I can barely get that in there, but it's this formula for that right here, doubling the angle. So that becomes 1/4 plus 1/2 cosine 2 theta plus, now these two together is a 1/8. Right, when I multiply those two together, I get 1/8, and then I'll distribute that through. So 1/8 plus 1/8 cosine 4 theta. Any questions there? One more thing I can do. I can put those two numbers together. 1/4 plus 1/8. And to do that, I can get a common denominator and add them up, and I get 3/8. So here's my final answer. 3/8 plus 1/2 cosine 2 theta plus 1/8 cosine 4 theta.
Would it be wrong or more correct to put parentheses around the 2 theta and the 4 theta?
It would be more correct. Yes,
Okay.
that would be more correct. All right. But again, I'm using this notation only to get you used to the idea that a lot of textbooks won't show that. It's weird. In the pre-cal book, they always put parentheses, which is correct. But once you get to calculus, they just kind of like stop doing it. It's really frustrating. But technically, it needs to be there.
It just looks more organized.
Yeah. You can tell that I teach calculus a lot because I rarely put parentheses around that because it's, the reason why is this, okay, just so you understand. The reason why is because, look, when you write cosine of 2 theta, that could be, it is not, but someone could think that's cosine of 2, right? Where the 2's in here and then the theta's here. That's what I told you earlier, right? That technically could be this. But if it was this, like if it was this, I would write the theta out front, not to confuse you. I would put the theta here and put cosine of 2 here, and then you know that the theta is not part of the 2. So in the way I write it, I would just make sure there's no confusion. If I really meant, like if I meant this and I wrote that, then that's really bad. So a good mathematician would actually write this so that there's no confusion. I'm not making a case for it being correct to not put parentheses. I'm just showing you why logically it's okay in calculus, I guess. All right, I want to give you one now, okay? I want to give you one, and I'm going to give you about, I don't know, 8 minutes. Let's see how you can do with this. I'm going to give you 8 minutes. You know what? I'm going to do it on the other page. That way you can go back and reference it if you need to. Where's the one I just did? Here's the one I just did. I'm going to zoom out so you can see it all. So here was the problem we just did. I want you to do the same problem, but I want you to do it for sine to the 4th theta. So instead of cosine raised to the 4th, I want you to do sine raised to the 4th. And I want you to rewrite it so that it has sines and cosines. No power is greater than 1. All right, let's take about 8 minutes. Do y'all want to be in groups? We haven't done groups in a while. I'll put you in groups. You don't have to go into them. But if you'd like to, you can. I just closed the breakout rooms, so everyone should be back here in about 45 seconds. And by the way, Brianna, you're going to be up. Okay, I think everybody is back. So Brianna, are you there?
Hello.
How's it going?
I'm good.
Good, good. Okay, we're able to get it, you think?
Yeah.
Okay. So what changes? I mean, I put up the old problem here just because I wanted to kind of see, you know, what's different, right? So we're using sine instead, right?
Yeah.
So sine goes here. And how did that change the next line?
It makes it 1 minus cosine.
Yeah, it's just a
theta.
minus, right? Minus
Yeah.
here, which makes this a minus. And then you FOIL this out over here?
Yes. So it'd be 1 minus 2 cosine 2 theta plus cosine squared 2 theta.
Yeah, so the only thing that changes there, there like that, right? This stays a plus, yes?
Yes.
Okay, so the only thing that's changing here is the signs, okay? Signs, plus or minus, not sine function. And then that changes this to a minus right there, right?
Mm-hmm.
Minus there, and then if you distribute a minus there, and then a minus here, and then a minus here, and then just a minus there, right?
Yeah. I also had a minus for the 1/8 part, the part that was connected to cosine 2 theta.
This right here.
Yeah, because when you redo that, the part that you're on, it'd be 1/4 parentheses
Oh
half
yeah, minus
1
right,
minus, yeah.
minus right there. I forgot we did it twice. So there, and then minus here, right?
Yep. So then it would be negative.
Negative here.
Yeah.
Yeah. So that's it. This is the final result right here.
Good.
Good, good. Okay, so while you were in your breakout rooms, I thought I would bring up something. So in my Cal 2 classes, I do my homework solutions, you know, for whatever homework I give them solution videos to watch. So I thought I'd bring up a solution to a problem from a homework assignment, and it just shows you some things here. So first of all, let's see. Go
I
ahead.
have a quick question about this problem.
Yes,
On the cosine squared 2 theta, like when we did the sine 4, how does that make it a minus there? Because wouldn't it still be like cosine squared 2 theta?
That's what I'm confused about too.
Wouldn't it still be
Because
what?
we're not taking like sine squared 2 theta anymore. We changed it to cosine squared 2 theta.
So it'd be 1
No.
minus cosine of 2 theta over 2.
We just rewrote sine to the 4th theta as sine squared theta squared, right?
Yeah, but the part like that's highlighted in blue, that
Oh,
doesn't
here.
change.
That should have been plus.
Wait, that wasn't changed, what?
That didn't change to a sine squared 2 theta.
In the final answer, I believe it's supposed to be plus 1/8 of 4 theta.
Okay, no, I see what you're saying. Okay, no, yeah, you're right. This is plus, hold on. So Brianna, go back and look at this. This is good. I'm glad you caught that. This right here was still cosine squared, right? Not sine squared. So yeah, that when I had said initially this was plus still 1 plus cosine. Brianna, you catch that?
Yeah, I got it.
Okay, yeah, that one still stays plus. So plus plus. Yes. Thank you, Anna Marie. Yeah, had this been sine squared, then it would get your minus.
That's where I messed up too on the same part.
Yeah, no, this stays plus because it's cosine.
Yeah, I was trying to figure out how I got a positive.
Yeah,
I'm so
I knew
confused.
when we first started doing it, I knew that the only thing that should change is this minus, but yeah, yeah. Okay. So I'm going to show you a video. I'm not sure if the audio is going to come up or not. So y'all let me know if you can hear the audio or not. This is me like 5 years ago doing a solution for a problem. All right. So tell me if you can hear it. All right. So remember, this is sine 2x. Like
I can hear it.
Yeah, you can hear that? Okay, so just look at what I have up there so far. This is a Cal 2 problem. We're trying to do what's called an integral. And look at what we have, cosine squared x, sine 2x. And see, I put parentheses around it, even though it was in the book, there was no parentheses. All right, so we can't work with those together right now because the argument here is x, the argument here is 2x. We either need them to both be x's or both 2x's. So I'm going to go and just use my double angle identity from pre-cal and rewrite sine 2x is 2 times sine x times cosine x dx. So that's the double angle identity. And put the cosine and cosine together, you get cosine cubed x times sine x. Okay, so that's just to show you I'm not going to continue with that problem. That's just to show you how I use that double angle identity. Okay, so here's another problem. Let's see. Okay, here. Sine theta, cosine theta, d theta. So we're making good progress here. Now I've got, okay, so here, this is just kind of to show you like how this stuff comes back up. And the thing that's weird about this is that you're taking pre-cal now, right? Then you're gonna take Cal 1. If you need Cal 2, this is Cal 2. So you won't see what we're doing right now. You're not gonna see it again until Cal, well, you'll see it, but like when you get to Cal 2 and you need it, it's not gonna be like you're gonna do like a day review on it. It's gonna be like, you know this, right? So like here, can you tell what I did from here to here?
You use the Pythagorean identity.
It's a Pythagorean identity. I just changed cosine squared theta into 1 minus sine squared theta, right? So throughout all this work I'm doing, let me see if I can find another one here. Let's see what I'm doing here. That's Pythagorean. I'm trying to find one where I use. That's one I just did. Does this look crazy to y'all or? I just want to show you one more thing if I can find it. Come on. Yeah, that might be the end. Anyway, okay, so you just have to take it on faith. It shows up quite a bit. Like all the stuff we're doing right now is going to show up again. So these are very important things to learn at this point. All right. Okay, we're going to proceed. Next thing that we want to do is we want to solve a trig equation. So we've done some solving of the trig equations already. And so here, let's take a look at this one. We're trying to solve sine theta, cosine theta equals -1/2. And we're told that theta needs to be between 0 and 2 pi. All right. So the way we solve trig equations, the way we tried doing them before, is we tried to do like factoring and things like that. Or treat them like quadratics if we could. Notice here we have sine times cosine, sine times cosine, right, equals -1/2. So how do we solve this, right? Like, when is sine theta times cosine theta equal to -1/2? Well, here's what you can't do. You can't just take each one of them and set them equal to -1/2. You are not allowed to do that. You can only do that if this right side was 0. If two things multiply to be 0, then you can set them each equal to 0. That's fine. But when they're equal to a number, you can't. All right. Do y'all understand why that is that way? I mean, it's a thing from college algebra, but it's important. It's called the zero factor property. So you can only have, I'll just give you an example. If I tell you I have something A times B, and I tell you it equals 0, then A has to be 0 or B has to be 0. There's no other way that two things can multiply to be 0 unless one of them one of them would have to be 0. If you try this with another number like 1, does this mean that A has to be 1 or B has to be 1? No. Can somebody give me an example of two numbers that multiply to be 1, but neither one of them is 1?
1/2 and 2.
1/2 and 2, right? What if this is a 1/2 times 2? Half of 2 is 1. So that would be true. And neither one of those is 1. So you cannot do this whenever you have a number other than 0 on the right-hand side. So two things multiplied to be -1/2, you cannot do this. So we're kind of stuck, right? However, we do remember this formula that sine of 2 theta is equal to 2 sine theta cosine theta. This is our formula that we had today. It's our double angle formula, isn't it? And do you see that it has sine theta cosine theta in it? And so if I divide both sides by 2, then I have a formula for sine theta cosine theta, don't I? That's what it is. And so what I'm going to do is I'm going to take this left-hand side, I'm going to replace the left-hand side with 1/2 sine of 2 theta. And that must equal -1/2 now. And the thing that's good about this is that now what I can do is multiply both sides by 2. And I get sine of 2 theta equals -1. Y'all with me on this? Y'all with me? Now that you have it down to a single trig function, you're saying sine of some angle is -1. So what we say to ourselves, I'm going to get rid of this. What we say to ourselves, okay, sine on the unit circle, sine is the y coordinate, and we want to know where the y coordinate of something is -1. That happens here, and that angle is 3 pi over 2, right? But we've already learned how to do this. We need to get all the solutions. So we need to be able to come back to it, or come back to it, or come back to it. So this is where we say you set the argument 2 theta equal to that angle 3 pi over 2 plus 2 pi k. K or n? What were we using? I always forget.
Okay.
Okay.
We were using k? Okay, all right. Be ready in calculus, you'll probably use n instead of k. I'm just letting you know. It'll probably be an n. Same thing though. Okay, so does this all make sense to everyone? What I did here? Because we've done this a few times. I mean, we did this was a few sections ago. You're gonna have a test on this in a week. So this is the general solutions. I set the argument equal to that. And now I'm gonna divide both sides by 2. So I divide this by 2, I get 3 pi over 4. I divide this by 2, the 2's go away. I'm going to put those together with a common denominator. And this gives me 3 pi plus 4 pi k over 4. Anyone remember what I'm going to start doing now to get my answers?
You're gonna start finding k's within the parameters.
Yeah, we're going to start just plugging in values of k and make sure that our answers are between 0 and 2 pi. So let's just start with k being 0. If k is 0, I get theta equals 3 pi over 4. Right? If I plug in 0 here for k, I just get the 3 pi over 4. And that is within 0 and 2 pi. Then I'll let k be 1. If k is 1, I get, let's see, what do I get? K is 1.
7 pi over 4.
7 pi over 4. Is that within 0 and 2 pi? How
Yeah.
do we check? Yeah, how do we check? We look at the number here, divide by that. 7 divided by 4 is smaller than 2. So we're still within 2 pi. And then if k is equal to 2, we get, let's see, 2 goes here, we get 8 pi, 9, 10, 11 pi, we get 11 pi over 4. But 11 divided by 4 is bigger than 2. So this is not going to work. And I could try a negative value for k, but I think you'll see if I plug in a negative value, you're going to get negative pi over 4. And that is not within 0 to 2 pi because it's negative and 0 to 2 pi is positive. So we have 2 solutions. Those are your 2 solutions. So that problem you can see involved using a formula that we learned today to solve it. If you try and do this any other way, you're going to get, well, you know what? At the end of class last time, weren't we solving a problem like this? I feel like we did. Hold on. Yeah. Look, remember this problem from last class at the very end? It was similar. It wasn't the same. It was this. And what we did was we squared both sides. So, okay, wasn't the same because it was addition, not multiplication. So, no, yeah, that won't work. All right. Okay, let's move on. What time is it? 12 minutes? All right, projectile motion. This is a word problem, all right? An object is propelled upward at an angle theta to the horizontal with an initial velocity of v sub 0 feet per second. See figure 32. So you've got this cannon. We're going to launch this projectile through the air, okay? And then it has an angle of theta. And it tells us that the velocity it comes out of the cannon with is given to us. Well, it's not given, it's a variable. It's v sub 0 feet per second. So I hope that in college algebra, you learn that on Earth, any object that you throw through the air, right? Any object that you throw through the air is going to travel in the shape of that's similar to a parabola. Okay, well, it is parabolic, in fact. Okay, so it's saying for this particular cannon, it says if air resistance is ignored, the range R, in other words, the horizontal distance the object travels is given by this function. So if you want to know how far this cannonball is going to go, then it will always be 1/16 times the velocity that the cannon was shot with squared sine theta cosine theta. So they're telling you that, right? And then they ask you part A and part B. So part A, it says show that this function here is equal to this. So can somebody tell me what they did here to get from here to here? The R of theta, the original function that's given to us, is 1/16 v sub 0 squared sine theta cosine theta. And that turns into 1/32 v sub 0 squared sine 2 theta. So what do they do?
They use I think they use the double angle formula.
Yes. Yep, they just did this. Look, this right here, look at the previous problem. Look what we just did on the previous problem. Remember when we were doing this and we said we had sine theta, cosine theta next to one another, and we said, oh, you can go back to the double angle formula and you can just solve this for sine theta, cosine theta and get this? That's what they did, okay? So all we're doing is we're replacing this with 1/2 sine 2 theta. And then we still have in front of it v sub 0 squared, and we still have 1/16. And now, can you see how the 1/16 and the 1/2 come together to give you 1/32 v sub 0 squared sine 2 theta? You're just putting those two fractions, multiplying them together. And that's what they wanted us to show, right? Show that that's really what the function is. Any questions on that? Part B, this one's the more interesting problem, part of the problem. Find the angle for which R is a maximum. So if this gives you R, right? If this equation gives you what R is, when would this be the biggest it could be? At what angle would this be the biggest it can be?
45 degrees.
45? Okay, so how can you prove that to me from the formula? So 1/32 is a number, right? We can't change that. 1/32 is 1/32, right? The speed which the ball comes out is going to be the speed that the ball comes out, and we're going to square it, whatever that number is, it is. Then we're going to multiply it times this, right? And what can you tell me about sine of any angle? Sine of any angle is always between what two values? Sine's between
0 and 2 pi.
that's the domain. I'm talking about the outputs of
Pi
the
over
sine.
2 and negative pi over 2.
That's still the inputs. I'm talking about the range of the sine function. -1 to 1, right? Any sine function, the range is -1 to 1, right? So it would be this thing in green, the whole thing. The biggest it could ever be is 1. Do you all agree? If I go with any other value, it's going to be smaller than 1, and it'll make this whole thing smaller. So since the biggest this can be is 1, then we want to know, when is sine of 2 theta 1? Right? That's the question. How can we make sure that this becomes as big as it can be? Because if this is the biggest it can be, then R is the biggest it can be. So we just need to solve this right here. So think about this like we just did. Sine is the y coordinate. Where's the y coordinate 1? Well, that happens up here at pi over 2. Right? And so what we know is that this argument 2 theta must be pi over 2 plus 2 pi k. Again, I'm getting the general solution. If we're at pi over 2, we could come all the way back around and be back at pi over 2. So I put the 2 pi k. I divide by 2, pi over 4 plus pi k. I divide everything by 2. I get a common denominator. I'm going faster through this because this is stuff that we've done already. And then I start letting k be 1, 2, 3, 4, or sorry, 0. If k is 0, I get theta is pi over 4. If k equals 1, then I get theta is 5 pi over 4. And I'm going to stop there. I'm stopping there because theta is the angle of the cannon, right? So think about your cannon. If you're going to shoot your cannon, what should your restriction on theta be? Like the smallest it should be is 0, right? And the biggest it should be is like straight up, which would be pi over 2. So I shouldn't be looking at 5 pi over 4. That's bigger than 90 degrees. So my only answer should be pi over 4. which is 45 degrees. So pi over 4 or 45 degrees would be the answer. Okay, don't worry too much about this problem. It was just about this formula, a way you can get sine theta, cosine theta in terms of a single trig function. Okay, all right, we have half angle formulas. Haven't done these yet. I think just because of time, I'm not going to start this. All we have is the half angle formulas, and we're done. Okay, so what I'll do is I'll leave that for next class. And I have a ton of homework to try and do on video, right? I still need to do a lot of video homework stuff. What was the
Yeah,
last one?
The one I had trouble with was 8.4.
Yeah. Let's see, what was the last one I did? 8.3. So I owe you still 8.4, 8.5, 8.6. I'll write that down. 8.4 through 8.6. Okay, I'll get working on those. I'll try and start today, but I have a feeling I'm going to have a lot of people in my office hours for my calculus class. But I'll try and do what I can today, and then if not, tomorrow. Any questions? Okay, well, if you feel good about this, this would be a good time for you to go back and start reviewing. Let's see, our first exam. How far did our first exam go? I'm going to look real quick just so I know where we're going to start the second exam.
It went up to 7.5.
There's only 7.5. Let's see. Yeah, let's see. The last thing. Oh, you did some sketching, right? That was it. So. Jeez. So we're supposed to have we did do graphs of sine and cosine on the test. We didn't do tangent. We didn't do all these. We didn't do phase shift. This is really a review topic, but I could put something on there from there. So what is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Potentially 10 sections on this test. That's quite a bit. Yeah, we only had 8 on the first one. So, all right. So start reviewing. I mean, this would be, if you're kind of comfortable with everything, just go back, because we're going to go all the way back to 7.7 to, test on. All right. Have a good day, everyone.
Real quick, do you know when you'll have the review for this test ready?
Well, I mean, I have to make homework solutions for 3 sections. Do you all have a preference what you want me to do first? I can do the review first. What do y'all
I
want?
prefer the review first.
Review first.
Yeah, review first. Yeah, I can do that. I can do the review. That I can get out probably later today.
Okay,
Get
thank
the
you.
review out, and then I'll work on the homework solution videos later.
Thank you.
Okay,
Thank you. Have a good day.
you too.
Thank you. Bye.
Bye-bye.